Now that we had all that build up, it's time to actually show the midpoint formula. So the midpoint formula. It's actually fairly easy, but let me write it out here. So the midpoint M, the midpoint M, when we're talking about points, we always have to have a name for them. So midpoint M of, let's say, line segment AB with endpoints so with endpoints A of x1, y1, and B x2, y2 is given by M equals, well, we don't really want to say M equals, actually here. Because M is a point, just like A is a point and B is a point. I wouldn't say A equals x1, y1. I wouldn't say B equals x2, y2. Because this is just saying A, this is a point, this is the coordinates. We're not really saying they equal each other. So if I want the point M, I'm not going to say M equals. I'm going to do it like this. M, and then what we have here, so we have x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. That's all there is to it. That's the midpoint formula. All right, so the point M is given by these coordinates. So this is the x coordinate. This is going to be our y coordinate. Now, once again, we'd like to see how this works, where it comes from. So we're going to start out like we did before. I have my endpoints, x1, y1. And we'll have x2, y2 over here. And our midpoint M. And of course, M is given by x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. All right, so this is the situation we have. Let's look at the x-coordinate for M. This is the x-coordinate right here, x1 plus x2 divided by 2. Now, you'll probably remember this as the average or the mean. Remember the mean, you add up the numbers and then you divide by how many numbers you have. Well, it's the same thing here. I'm trying to find the average between x1 and x2. The average of these two x's will get me the x that's in between. So this part tells me, okay, I know that M is going to go along here. M is somewhere along here. Now I have to narrow it down with the y's. Y is going to tell me how far up or down. So what's the average of the y's? Well, the average of the y's, the top y, y2 and y1, it's going to go right through the center. So through the center. And wherever these two crisscross, that's our midpoint. So that's where you get the midpoint formula. So let me do an example of the midpoint formula. They might say, well, since this is geometry, let's shake it up a little bit. How about this? Prove that if, and we've been using A and B. We'll use P and Q. We'll use PQ. Prove that if PQ, so line segment PQ has endpoints. So it has endpoints. And let's see. Oh, that's right. We're using P and Q this time. So how about P of -4, comma 1, and Q, the coordinate for Q can be, how about 2, -3. All right. So those are my endpoints. So prove that if PQ has these endpoints, then the midpoint, and we're going to call this midpoint M. We'll just stay with M for midpoint. Makes it easy. then the midpoint M of PQ lies in quadrant 3. All right. So prove that if PQ has endpoints of -4, 1, and 2, -3, then the midpoint M of PQ lies in quadrant 3. So let's find out if that's true or not. Let's see if we can prove it. So I would say, using the midpoint formula, I'm going to do our proof here. So using the midpoint formula, and substituting coordinates, because I say substituting coordinates because these are the coordinates, but I'm substituting them as x and y. So again, like this is my x1, this is y1, this over here, that's x2, because that's my second point, and that's going to be y2. That's why I'm substituting in for the coordinates into the formula, because the formula is given in terms of x's and y's. So let's see here. So if I substitute into the coordinates, I get m of -4 plus 2 divided by 2, comma, 1 plus -3 divided by 2. All right. Now, if I do the arithmetic on this one, I get m of -1, comma, -1. All right, so far so good. So that's the midpoint. The midpoint is -1, comma, -1. But again, we're still in our proof. So I still have to go from here to saying that it's in quadrant 3. So here's what I'm going to do. I got to get it from here to saying that's quadrant 3. Since x and y are both negative, M lies in quadrant 3. And I'm going to say in parentheses, by definition of quadrants. Because you always want to give a reason. So I'm just going to say by definition of quadrants. Because the definition of quadrant 3 is that x and y are both negative. Because if you don't remember, let me just draw a small little thing right here. Remember, quadrant 1 starts over here. That's when x and y are both positive. Then quadrant 2, because we go counterclockwise. Quadrant 2, so now my x's are negative, but my y's are still positive. Quadrant 3 is when they're both negative. And of course, quadrant 4 over here, x's are positive, but now the y's are negative. Right? So that's how we define quadrants. It's based on is x positive or negative, and is y positive or negative. So that's why I said by definition of quadrants. So we have proven that M lies in quadrant 3. And that's how you use the midpoint formula.